Okay, so welcome back. Today we'll have a look at flying an RNP approach, or required navigation performance approach, for those of you that have not understood or flown one of these before. So we'll fly into Bristol. At the moment we're just heading up in the cruise towards the Brest Peninsula. So at some point in the cruise we would have put the arrival in. So at the moment I've zoomed out just so you can have a better view of things that are in the FMC. If we go into the DEP arrive page, the arrival, you can see we've got the TOJAC 1 Bravo arrival selected. So if we, on the EFIS panel, go into plan and reduce the scale down, go into the legs page on the CDU, and then take ourselves towards the final part. So you have Islay Exmoor, and then you can step through. So being based at Bristol, a little bit of local knowledge. So after Exmoor it's going to fly to the BRI. So what we'll do is we'll put the arrival in. So arrival, and select the RNAV 27, and for this particular time we'll go via Baxon because it gives us a nice transition. So just pop that in at the moment, go back to the legs page, and then just step through so you can see goes to the BRI. So you can see it goes to the BRI here. So if you just line select the BRI, and then put /-8 and put that on top, and then join that up with Baxon. You'll see that gives you a downwind left hand point around. I'll just step through there. You can see it wants to be at Baxon above 4,000 feet, and if I select data, wants to be at LROV above 2,500 feet. So just for those of you that haven't flown many RNAV approaches or any RNAV approaches, we want to have a look and see what altitude it wants to be at LROV. So if we press delete and delete LROV without executing that, we can see that at LROV it wants to be 3,464 feet. So just to give us a little bit of a shallower segment, we can put an altitude that's above 2,500 feet but that's below 3,000 feet, and that'll give us a shallower segment to kind of manage the energy a little bit easier. So if we go back to LROV and say we want to be 180 knots, so we put 180 and let's call it 2,700 feet, and put that in at LROV. See, that's selected here, and then if I execute that, that's going to give us an altitude that's above 2,500 but below the path that it wants to be at, so you've got a bit better energy management here. If you then look for LROV, or the GD27 Foxtrot, which is the final descent point, what we'd normally do for an RNAV approach here is put a 2-mile range ring. As you can see, that's at 2,500 feet, Bristol's at 600, so that only leaves you really 1,900 feet before the runway, so for the line selection. So if we select that and put that into the fix page, let's say put a 3-mile range ring around that instead, and that draws a nice range ring here. So normally draw a 2-mile range ring, and at that point, as you intersect this, your pilot monitoring would call you approaching glide path, at which point you would be at flaps 5 and then call for gear down flaps 15, and then inside here in this part before the final descent, you could then set the final altitude ready for the final part of the descent. We'll talk about that a little bit later. So that's set us up initially. So in the cruise then we have done the track and distance checks. As it's an RNAV approach, we also require that to be 0.3. So again, for those of you that don't understand the terminology down here, so here we have the RMP, which is the required navigation performance, is set on 2 at the moment, and the actual performance is 0.05. So for the RMP approaches that we'll be looking to fly, we want that to end up being at 0.3 at that final descent point. So to check that the aeroplane's going to do that, if we go back to plan, you would, on the aeroplane, come here, and this waypoint here would say RMP 0.3. So you know then that the aeroplane's going to transition to 0.3 for the final part of the approach. This aeroplane has integrated approach navigation, so IAN, for those of you that know the terminology, which means you can basically fly this thing like an ILS, and you will actually use approach button for the final stages of it, but instead of having glide slope and localizer, you'll have FAC, so final approach course, and GP for glide path, which you'll see on the PFD later. So there we are, that's all in. So that we'd have sorted that out in the cruise, and then the next thing that we'd look to do would be the descent procedure. So starting with the descent procedure, then we're checking the RMP and AMP. It's making sure, obviously, if this is higher than 0.3 now, there's a good chance that once we transition for the final part of the approach, we are going to get enable navigation, enable RMP rather, which means we can't technically fly the approach. So it's a good heads up at the moment. We know that it's actually achieving 0.05, and it's going to transition to 0.3 here later on in the approach. So AMP is behaving itself, so that's good. Coming up the top, so center tank fuel pumps are off. There's nothing in the center tank. The fuel is balanced. Pressurization panel's good, set 650 feet for the landing altitude, and that's good for Bristol. 35,000 feet is set in the pressurization panel, and we achieved 35,000 feet, so we won't get an off-schedule descent. Performance we'd have calculated to make sure that we can land with the weight and wind. For those of you that don't know how to set the approach speeds up, so in the CDU, easiest way, so once the arrival's in this, you have a sensible amount of fuel to land with. If you select progress page, and you can see that we're expecting to land into Bristol with 3 tons of fuel. If we go in the performance page, the zero fuel weight is 62 tons. So 62 tons plus the 3 tons that we'll be landing with means that we'll be landing at 65 tons. So if we go into the approach ref page and put 65 tons in here, that changes the speeds in here. We'll set up for a flaps 40. So if you double select here, that puts the flaps 40 and the VREF 141 speed, which appears here. Minima from the charts for the RNAV approach will be 1,000 feet. So we can wind our barrow minimums to 1,000 feet. Just make sure we do that on both sides. So barrow set to 1,000 on both sides. So approach aids, as it's an RNAV approach, we don't want to have an ILS selected up here because we'll be using IAN. So just park the ILS into the non-selected side. inbound course for the RNAV approach is 267. So we set 267, and obviously needs to be set both sides. From the performance calculation, we'll say that we calculated that we need auto brakes 3. And then so we would brief, and then we would do the descent checklist. Okay, so here we are at 33,000 feet, LNAV and VNAV engaged. So the speeds will be managed by the FMC. So if we look on the descent page, the speeds here, it's going to do .77 until it transitions speed 270 knots, and then it'll automatically change 250 knots below flight level 100, and then the other speeds as we've put into the computer a bit further on. So we'll do our best to keep the aeroplane in VNAV path, and hopefully let manage it until we get to final approach, and then we'll use speed intervene to manage it for the last bit. So VNAV path's in, so let's pretend we've been cleared down to flight level 160. So put that into 160, so there's a lower altitude in here. So as it's gone through the top of descent point, we've got retard, so the thrust levers will come back to idle. And the aeroplane will target 270 knots. There's the thrust levers come back to idle. The real aeroplane actually does that a fair bit quicker than that, so they'll come back to idle. We'll rejoin the flight in a moment, a little bit further on in the descent and a little bit closer to Bristol itself. So here we are joining the aeroplane further on in the descent, just about to approach flight level 100, still on standard at the moment, and just thought it would be an opportunity just to demonstrate something else as well. So the auto throttle mode is in arm here, so the thrust levers have closed and it's still washing away a little bit on the speed. So just before it starts to come back to 250 knots, just to let you know, if you set it up with your FMC like the aeroplane, that you can actually manually increase the thrust to get yourself back onto speed before the aeroplane transitions to VNAV speed and does something about it. It is as lazy as that on the aeroplane as well. So you can just keep the speed that you intend to fly. So thrust levers up as it approaches the speed that you want, and you can manually close the thrust levers again, and the auto throttle mode stays just in the armed position. So here we are approaching 10,000 feet. It's actually reduced to 240 knots because there's the speed restriction was at Exmoor, 240 knots at Exmoor rather. So through 10,000 feet, so check the lights are on and the seatbelt signs are on. So one other thing, let's just imagine we've been cleared now down to 4,000 feet, so set 4,000 feet in the altitude window, and we would press standard then to go to the QNH, which we'll say is set at 1004, and I'll just leave the first officer's side one, and there we go. So alt disagree showing up here shows that I've set a different reference than the first officer's side. So we've got alt disagree there. If we just move across and then move this side to standard, and then the alt disagree disappears. Set 1004. Obviously one of the biggest important things with an RNAV approach is that the correct QNH is set, because the aeroplane generates its own path based on the barometric pressure altitude. If you've misset that, it will fly you into the ground. So here we are, just back on speed, approaching our waypoint that we drew. And by this point we would normally be on radar vectors from Bristol radar. Just keep everything in set up with the RNAV path same, just to keep the aeroplane in VNAV path and managed by the speeds all managed by the aeroplane. So with everything set, we've got the seatbelt signs on, we have the lights on just to show. So fixed landing lights, seatbelt signs on. It's an RNAV approach, so we will select the VSD. I'll actually put it on this side because it's on the NG it's a little bit imposing on the screen, so put on this side, and then so we've set QNH both sides, then we're good to complete the approach checklist. So backsun set to be above 4,000 feet in VNAV path, all looking good. So we can have a look on the CDU on the progress page. Shows we've got 26 miles left to run, landing with 3 tons. Here's the decel point. So to achieve the 180 knots that we put in for LROV, you'd expect the aeroplane then to start managing that speed at the deceleration point and start to bring that towards up speed. The aeroplane won't bring that below up speed until you've selected flaps. So even if you've told it that you want to be 180 knots, unless you select the flaps, it won't reduce that below up speed. So you can see here on the RNAV start, the RMP is changed to 1, and we want to make sure that that's changed to 0.3 then before we start the final descent from the GD27 Foxtrot. So there's the chime to say we're approaching 4,000 feet. We can then say we're cleared to 2,500 feet for LROV, so 2,500 feet in the altitude window. Here's the decel point. Just keep an eye, you see the target speed starting to reduce. $17 miles left to go. Biggest trick here is to try and make sure that you maintain VNAV path. It becomes a little trickier and harder work if that reverts to VNAV speed, to get yourself back on the path. So here we are turning at backsun. Speeds come back to up speed, so select flaps 1. Flaps 1 manoeuvring speed has appeared here, and again it won't reduce the speed now. I've told it I want to be 180 knots at LROV, but it can't reduce below flaps 1 manoeuvring speed until I select flaps 5. I select flaps 5. And that would have reduced that to 180 knots. This simulator is not perfect, but so on the inbound, so if we arm the approach, so here we've got FAC, final approach course and glide path, which appear armed in white. So we know that they should transition at the right time once it captures. Here are the anticipation cues, so it looks very much like an ILS. So final approach course captured here. So the equivalent of localizer capture. And the other thing on here, if you fly in this not using IAN, you would need to select, so approaching glide path here, so we go gear down flaps 15. Arm the speed brake. Pilot monitoring. Put the engine start switches to continuous. So we've got that little bit of energy in hand because we put a shallower path in. So normally that would have coincidentally caught the glide path. So if we weren't flying this with IAN, we would then need to select 1000 for the minima here to allow that to continue down in VNAV path. Here on an IAN approach, you don't need to do that. One less step left to do. As this captures, we'll expect glide path to go green. There you go. Glide path captured. The missed approach we can set for 3,000 feet, and then we can reconfigure. So if we go, we are in speed intervene, so we go flaps 25 and speed flaps 25 maneuvering speed. And then just as a final check, so 64.9 tons, flap 40 reference speed 141, which we've set. So there's nothing else to change on here. So you can see 2 reds, 2 whites, so the path looks good. And through flaps 25 to flaps 40. And assuming there's no increments to add, we'll just add the VREF plus 5. So it's 146. And plus 5 usually will put the bottom of the set it bug, speed setting bug, just sat on the top of the VREF. And here we go. So pretty much same as flying an ILS. It projects the descent path outwards. Less things to do. Don't have to set the minima in here to keep the aeroplane descending in VNAV path. And we get the cues that look very much like an ILS. If you look here, the RMP has changed to 0.3. And if the actual navigation performance went outside or greater than 0.3, we would get a message telling us enable required navigation performance. There you go, and then off to land. So hope that's been clear enough for you. Any questions, stick in the comments and I'll do my best to help you out.